In Enterprise Besu, compliance is part of the design, not a wrapper around it. It influences participation, data placement, audit evidence, and accountability across jurisdictions. In this module, we'll connect regulatory expectations to practical architecture choices. You've already built the core Besu toolkit: network models, node architecture, consensus, permissioning, and smart contracts. Now we'll look at how those choices support compliance requirements, such as auditability, privacy, governance controls, and regulatory alignment. A Besu network can be technically sound and still fail the enterprise test. Compliance is what helps regulators, participants, and auditors trust how the system operates, who is responsible, and whether the right evidence exists. Regulatory requirements need to enter the architecture conversation early. They can shape consensus choices, permissioning, privacy, node locations, and decisions about what belongs on-chain or off-chain. Data residency may limit hosting regions. Retention rules affect backups, logs, and archives. Audit obligations define what evidence must be captured from the start. The goal is to design controls that produce trustworthy operational proof, instead of scrambling for proof after launch. In Besu, auditability starts with the immutable ledger. Each transaction is anchored by a hash, block number, timestamp, and any smart contract events it emits. Consensus strengthens that record because validated blocks become shared evidence. But enterprise traceability needs more than chain data. Those anchors must connect to user identities, application actions, access logs, and operational records. Governance then defines who may inspect that evidence, when, and for what purpose. For compliance, the aim is not to store every detail on-chain. It is to create a reliable evidence trail. Smart contracts should emit events for key milestones, such as approvals, transfers, settlements, and status changes. Transaction metadata adds the sending account, contract interaction, gas used, and block inclusion. Application logs complete the story by linking user sessions and API calls to the transaction hash. Keep sensitive data off-chain using hashes, identifiers, or references instead. In an enterprise Besu network, accountability must connect technical activity back to real organizations. Permissioning limits which nodes, applications, and accounts can participate, but compliance also needs reliable identity mapping. Each address and node identity should trace to an approved participant, their role, and their governance obligations. That mapping must be auditable and protected. During onboarding, offboarding, incidents, disputes, or regulatory requests, everyone should know who is responsible. Treat the blockchain as a verification layer, not a filing cabinet for sensitive records. Personal data, medical details, trade secrets, and confidential documents should usually stay off-chain, because replicated data is hard to edit, delete, or contain. Encryption helps, but it is not a permanent escape hatch if keys leak or algorithms weaken. A safer pattern is data minimization. Store hashes, references, identifiers, or proofs on-chain, while keeping the underlying data in controlled systems. In compliant Besu architectures, sensitive records stay in systems built for control, such as databases, document vaults, or content platforms. The chain receives only a hash, commitment, reference identifier, or status. That gives participants proof of sequence and integrity without exposing regulated data. Applications retrieve the real record through authorized APIs. Be careful with references too. Names, paths, or predictable IDs can leak metadata. The rule is simple: never put raw regulated data on-chain. Access control in a Besu network is layered. Start by deciding which organizations are allowed to run nodes and participate. Then control which accounts can submit transactions or invoke sensitive functions. For confidential business processes, use private transactions or privacy groups so data is visible only to intended parties. And do not rely on blockchain controls alone. Enterprise identity, roles, approvals, and audit trails still need to govern what each end user can do through the application. Regulatory alignment depends on the industry and use case. In finance, the priorities are auditability, transaction integrity, AML and KYC integration, and clear segregation of duties. In supply chains, the design should prove provenance and chain of custody. In healthcare, privacy, consent, and off-chain data minimization dominate. For public sector systems, emphasize transparency, records retention, accessibility, and accountability. Start with the regulatory driver, then map it to architecture controls. In multi-organization Besu networks, geography becomes part of the architecture. You need to know where nodes run, where logs and backups are stored, where keys are managed, and where off-chain data lives. Regulated data may not be allowed to cross borders, and even metadata can expose sensitive business activity. Cloud region choices, privacy groups, and storage patterns should reflect those constraints. Governance agreements should also state who is responsible for compliance in each jurisdiction. Retention starts by identifying each type of record and how long it must live. Transactions, application logs, node logs, identity mappings, documents, backups, and audit evidence. Besu preserves on-chain history, but off-chain supporting records still need policy-driven storage. When litigation or an inquiry begins, normal disposal stops, and legal hold preserves evidence. Archives should be protected, searchable, and tightly controlled. Retention must also align with privacy rules, especially where off-chain data may require deletion or restriction. Compliance in Besu is not a one-time design decision. It is an operating discipline. Define clear policies for onboarding participants, changing permissions, upgrading contracts, and handling data. Then make those controls observable through logs, approvals, configuration history, and transaction evidence. Reviews should happen regularly, because regulations, participants, and use cases change. Most importantly, ownership must be shared across legal, security, operations, application teams, and network governance, so compliance remains active in day-to-day decisions. Compliance-ready Besu networks are designed, not added later. Use the ledger for integrity and audit anchors, keep sensitive data off-chain, and preserve the evidence regulators need across logs, identities, governance, and operations. From here, security architecture, key management, monitoring, and AI risks build on that foundation.